Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter, we're going to take a look at how we might handle missing values in our data set. Now, missing values are going to come in two different forms because there's different reasons why attributes might be missing. The first would be they were not recorded because in the context of a record they were not relevant. We would call this a do not care condition. For example, if you are a brand new donor in my file, I don't have a contribution amount from last year because you weren't a donor last year. So it is contextually irrelevant because you weren't a donor in the prior year. Other times it was maybe forgotten, erased, maybe the person refused to provide us the data, so perhaps they wouldn't tell us their gender, for example. So we had to use a value of unknown. This is called lost data, and we're going to handle them differently. Do not care and lost can be handled in different ways. And always keep in mind that the issue of lost data is just as important a problem to data mining as it is for statistical reasoning. It's a big deal. You need to make careful, cautious decisions about how you're going to handle missing values. Now, we may choose to handle missing values in different ways. There are sequential methods that would include things like deleting the rows that have missing data, or replacing the missing values with substitutions like mean, mode, all possible values, the closest fit case. I mean, you can come up with lots of different ways to say, I'm going to take a guess, basically, to what the missing value is. And then there are parallel methods. You'll see in some of our data mining techniques, there are actually rules and algorithms that can be built in to handle missing data, and basically to treat them as a do not care or a lost values condition. So I'm going to look at a few different ways that we can handle some missing values and show you some different mechanisms. I'm going to start by pulling out a statistics node here. And I'm going to begin by executing the statistics, and when I look at the statistics table, one of the values I have here is the number of missing values, and I'm going to use this as part of a computation now to take and say I want to know is basically the row count here that this is, and then the number of missing values, so I can compute the percentage that are missing. So let's turn around and add a math formula to this, and I'm going to turn around and say I want to take the row count right there, but I want to divide the number of missing values divided by the row count to get the percent that are missing. And I'm going to look at my data now, and I can start to look and say, okay, so I've got, look, okay, for current year total given, I've got 99% of the data is missing. Here I'm missing 14%, 25%, 0%. So I can start to look at these and say, I can use these as a filter. So if I were to sort this in descending sequence, I might turn around right now and say slide over this column. So I can scroll all the way over and say, you know, total given, total number of gifts, prior year total given. These columns, if 90% of the data is missing, they're not going to provide a threshold. In fact, there seems to be a nice cutoff here at 88% missing, and that seems to be about the cutoff. So I might turn around and say, I'm going to take each of these gifts, each of these columns, and remove them from my data set just using a column filter. But if I come here into the node repository, I could do that manually like you saw me just do, but there is a missing value column filter function. And I can just apply this directly. And I can tell that I want to change this threshold down to 80, where I saw that was a good marker, and say include all of the columns that I'm going to run this against, and execute it. So I started with 24 columns. My output now is down to 14. So 10 of the columns were removed because they had so many missing values. Another way of handling this, of course, we talked about would be putting in your own missing values. So in this case, there's also a missing value node. And I'm going to take this and connect it, and I can instruct what to do as a default level when data is missing. So if it's a string, an integer, or at the column level. So I can come by here, for example, and say if city is null, what do I want to do? Do nothing, put a fixed value, the most frequent value, the next row's value, the previous row's value. This would be the mode, because this is a string. I'm going to turn around and say I'm going to do a fixed value. Instead of null, I'm going to say use a city of unknown. And if I look and say total number of gifts, I'm going to add that, and I might on this one now say I want to use the mean. If I don't know that, and I've made a decision after doing analysis that seems like the right thing for me to do. So I can continue to do this all the way through every column that might have missing values. And it does warn me that there are still columns that have missing values like type. But as you go through and add each column that you feel you need to have a value for, this is for value assignment, this is removing them. So I might actually do something, if I was actually building this out in reality, I'd probably do that. And say first I'm going to remove the columns that are missing so much data that they're useless. Then I'm going to come in here and take the missing value column and apply that. And I might turn here as a default and say whenever it's a string, the default is going to be unknown. And whenever it's an integer, I want a default value to be 0. And whenever it's a double, I want it to be 0. And now I'll execute it. And now my data is now filled, and everywhere where I didn't have a value now has a value of unknown. So as you saw with the 9 missing value nodes, I can take care of missing values with a lot of different solutions by manually replacing them. I can delete them, assign most common values, replace with mean, median, max, min, fixed values. These are decisions that you have to make while understanding your data. There's no way for somebody to tell you what the right solution is. And it's always a good idea to try to understand the impact of what it is you're about to do on any type of data mining exercise that you undertake. For example, you might take, I'm going to show you in the coming slide here, let's say we take a regression formula and we want to see what would the regression formula look like if we used the mean or whether we used 0. How would that change the regression formula and how might that look? Well, in this example, I've used missing values and replaced by the mean on the left-hand side of the screen, and then I've replaced the missing values by 0 on the right-hand side of the screen. And if we focus in now on the r² values that we see, you can see that the r² is significantly different and tells you again, so this is what I mean by look at your procedures, look at the data mining operations you're going to perform, and understand the impacts of what you do before you make a decision on how to handle missing values. That completes this chapter of the class. Feel free to move on to the next chapter.